Welcome to our third lesson on factoring quadratics using the decomposition method. Today we will be practicing working with quadratic functions and equations and how we can factor them. So, to begin, we have some vocabulary starting with simplify. When you're asked to simplify an expression, we want you to expand it and collect like terms as much as you can. We will also be using the distributive property. So if you recall, that pretty much looks like when we have a term multiplied by a bracket, we have to distribute that term by multiplication through the bracket. So let's look at this first example, and that should make a little bit more sense. So here we have 2x times 3 plus x. So 2x is one term in itself, and we will be using the distributive property to multiply this through the bracket. So I will just rewrite, and I write my x variable in cursive so it looks different than my multiplication. So the first term will become 6x, and the next term is 2x squared. So here we have expanded, and there are no like terms to collect. So we are pretty much done here, and that's your final answer. Now, factoring is the opposite of expanding. So we now want to collect a common variable here, or a common factor here, to write our expression in a more simplified way. And I have a diagram here as well to help us. So the expression that we are trying to factor is 6x squared minus 9x. So first we want to see if these two terms have anything in common, any common factors. So you should be able to see that their coefficients 6 and -9 are both multiples of 3. So we can definitely factor out a 3. And they both share the variable x. So their common term is 3x. Now, I want to set up my bracket since I have two terms, and I'm thinking 3x, what do I have to multiply it by to get 6x squared? And it would be 2x. And similarly, I think, what do I have to multiply 3x by to get -9x? And that would be -3. So this in factored form is 3x times 2x minus 3. Now looking over here, we are using algebraic tiles to represent this expression as the product of its factors. So if we were to form 3x here, so each of these squares have a width of x, so we have a total of 3x. We also have these rectangles here, which have a length of x and a width of -1. And if you look inside each of these tiles, the expression that's inside the tile is the area of that specific shape. So a square that is x by x has an area of x squared. And so if you add up all of these to get the total area, you should see that this is equal to 6x squared minus 9x. So essentially what we are doing when we factor is that we are imagining the expression as an area and trying to see if we can form a square or a rectangle that has two side lengths that would be the factors, and if we multiply them, we get the area again. So looking now here at the algebraic tiles. So we will be using this throughout the course to help visualize some of the concepts a little better. So these are the main 6 tiles that we have. So again, each of these have a width and a length. So here we have a square that's 1 by 1. And here we would have it as 1 and -1. And my x here, the x squared, again has x and x. And these rectangles are x by 1, or similarly, x and -1. And in this case, we also have x and times -x. And so when we are representing the subtractions, we use the darker color, and we should be able to, for example, like here, see we have 6x squared minus 9x. So for this lesson, there is an attached activity with GeoGebra where you can practice using algebraic tiles. So definitely explore that and see if you have any questions about how to set up your algebraic tiles. Now we will look at this example here with the equation 3x plus 4 equals 10. So we're going to now use those algebraic tiles. So starting with 3x, and we have 4 tiles. And this is equal to 10. So, and these ones are all the light pink because they are positive values. We see that we have 4 tiles on both sides, which already provide us that equality. So now these 3 rectangles are formed from 6 squares. So essentially, those 6 have to be divided into 3 groups. And how we do that is to form uh, squares that are 2 by 1. Or sorry, rectangles that are 2 by 1. And so our x would be 2 as it represents that length that was originally x. Now, we are looking at quadratic equations now, or expressions, and we want to factor them. So we now are being introduced to a new way to factor our quadratic expressions, which is decomposing method or the decomposition method. How that works is we want to break the expression, the quadratic expression, into different parts, and that's essentially what decomposing is, in order to make groups that will be our factors. So we want to find two numbers whose sum is going to be 4 and whose product is going to be I will use colors to help out here. Whose product is going to be here -5. And I've already done this example for you, but the two numbers that fit this description would be 5 and -1. And you can check. 5 plus -1 is 4, and 5 times -1 is -5. And so that's what you see here, where I wrote plus 4x, positive 4x, as positive 5x minus x. So I'm using those two numbers now to decompose my expression. And now, factoring it, I'll show you the factoring here. Oh, I missed an x in there. Hold on. So here we can see that I don't right away have a grouping, but I do see two of my terms have 5s. So I want to rearrange a little bit, and I'll actually write it this way. And this is the same expression. Now, these first two terms have something in common, and so do these two. So we will factor And we see that now we have an x minus 1 in both of these. So I will also factor out the x minus 1, and I have x left over from the first term and 5 left over from the second term. So our final answer in factored form is x minus 1 and x plus 5. And if we are visualizing those tiles again, these would be x minus 1 and x plus 5 are my width and length. And my area here is x squared plus 4x minus 5, which is the expression that I started with. So now you can take a moment to try these three, and I'll be right back and I'll give you the answer so you can check. So you should have received the following answers. So let's just take a look at them a little bit more. So here, 3 and 4 were the two numbers where their sum is 7 and their product is 1 and 12. So 12. And if you've used the decomposition method just the way we did here, you should have found the same answer. I hope you have noticed by now the trend that the two numbers you found are the same ones that are going to appear in your factored. So if you found positive 3 and 4, here we see positive 3 and positive 4. In the next example, where we have negative 7 and negative 3, that is precisely what we have here. And you can try expanding this and see that you will get the same expanded expression. And for number C, if you try to find two numbers where their sum is 4 and their product is 5, you should have gotten that there's no solution. So sometimes it's not possible to use the decomposition method. And so we will be learning other methods that we can use. But in this case, it was just not possible. Now, let's look at examples where a is not equal to 1. So here we are given 4x squared plus 16x minus 48. So the first thing you're always going to check is, do I have a greatest common factor here? And we will be seeing here that yes, 4 is actually a common factor of 4, 16, and 48, or negative 48. So we will factor 4 out, and here we have 1, 4, and negative 12. So now, I'll give you a moment, try to factor the expression inside the bracket using decomposition method. So you should have gotten 4 times x plus 6 times x minus 2. And greatest common factor here, which was 4, is essentially the largest positive integer and variable that we have with the highest degree that divides two or more terms. And it will have no remainder because it's fully divisible. So in our example above, 4 is a factor of 4, 16, and negative 48. So we were able to factor it out or divide all of those terms by 4 and have no remainder. And so you always want to check if you have the greatest common factor before you start decomposition because it actually helps when you are working with smaller numbers for decomposition. So if you try to work with a product of 4 and negative 48 and a sum of 16, that was way harder than working with 4 and negative 12. So now we have another try it now. So try determining what the greatest common factor in each of these expressions is. And for this one, just factor out the greatest common factor. You do not need to go continue on to factor with the decomposition method. You can just factor out the greatest common factor. So these are the answers we got here. So in the first question, the greatest common factor is 3. In the second one, it's 2. And for that one, if you were a little unsure, you can always factor out the smallest number that you can think of, so 2 in this case, and see whether you can factor out anything else from the bracket. So I checked here 12, 9, and 16. They do not have a common factor, so I would be done here. And in the last example, the greatest common factor, is simply a variable b. All three terms share b, so we were able to factor it out. And now we have a quadratic expression in with the variable a, which we would be able to check for factoring with decomposition. So this is just a key idea of our lesson from today. So if you have quadratic expressions of the form x squared plus bx plus c, so a would be the coefficient of x squared, and that is 1 in these examples. And essentially what we were working with today was to find two numbers where their sum is b and their product is a and c, which a was 1, so it was essentially just c. So if we are factoring these expressions, we are looking for two integers r and s such that their sum is b and their product is c. And here's a little chart to help us put all of that information together, specifically paying attention to the signs. If we have a positive or negative b and a positive or negative c. Um, and this would be kind of like a cheat sheet for how to do it. But if you follow the decomposition method, you will be able to solve any or factor any quadratic expression without necessarily memorizing this table. That one gives you precise steps that you can follow. So for today, you have another practice set where I encourage you to try either writing on a tablet or working by hand to write these out. And please include all the exponents. Pay attention to the variables that are used. There are variables other than x that are being used. In the first question, just expand and simplify the same way we did. Expand using distributive property and collect like terms. In the second one, factor out just the greatest common factor. You do not need to, if it's a quadratic expression, do not apply the decomposition method, just the greatest common factor. 3, we have a short word problem using the algebraic tiles or the concept we learned from the algebraic tiles. And another question about algebraic tiles. And just at the end, we have a lot of decomposition method factoring. This is a very key concept for quadratic equations and expressions, so I highly encourage you to try this, especially if the first few questions you're getting it wrong. Please work through all of them and make sure you fully understand this concept. And I've also, in this lesson, attached a video where 2 years ago, 3 years ago now, a mathematician came up with a innovative way to solve quadratic expressions where you're not trying the guess and check method of finding the product and the sum. So if you are interested in algebra and cool math tricks, please check that out, and you can reflect on it in the exit ticket for this lesson as well. If you have any questions, again, please feel free to send me an email or leave a comment on the Google Classroom post. Happy learning!